Hello, everyone. We're live, I think. Sorry for the weird scheduling confusion. I'm just typing a message in the channel now to kind of let people know that we're starting now, not in an hour like it says. So I have Alex here. We're going to introduce him in a second, but I'm just going to finish typing up this message and maybe let some people stream in as, the scheduling weirdness is being processed by everyone. We're going to be talking about storage migrations today, which is a pretty interesting and, necessarily complicated topic, but it shows off some really unique features of Substrate. So that should be interesting. How was your Sub-Zero, Alex? Did you attend all the sessions and everything? Did you presented anything? No?
No. I was thinking about presenting something, but I ended up on a meditation retreat, and I was like, no, it collides.
I remember that.
Yeah.
That sounds really cool. Did you enjoy the meditation retreat?
It was pretty intense sometimes, but it was also cool.
An intense meditation retreat. I like it. That's my kind of meditation.
Well, I was trying to relax, but sometimes your head gets in the way of you too.
I do know that. Well, that's very cool. I'll have to ask you some more about that because that sounds really interesting. But I think I see that there are some people starting to stream in, so that makes me feel like now's a good time to kind of kick things off. So just to officially get started, please use the troll box like Alex over there. This is Substrate Seminar. I realized last week I did a terrible job of introducing the seminar and myself and everything. So this is a weekly collaborative learning call. I hope you can already tell it's super duper informal. This is where we get together once a week and just kind of talk about different things related to Substrate development. We try to have guests who, present their areas of expertise because, as I'm sure a lot of you know, Substrate's a big area to try to get the whole thing. So we actually have two people who are going to be presenting today, but right now I have Alex on the screen with me, and Alex is going to be talking about as I said, runtime upgrades. So we'll talk a little bit about what that means. But I thought it would be fun for Alex to kind of start off by introducing himself by explaining a little bit about his role here at Parity. Alex, you're a runtime engineer, and I didn't even really fully understand what that role meant until a couple months after being here at Parity. And so, I'm going to go ahead and hand it over to you now, and I'd love for you to talk a little bit about what you do here at Parity and kind of use that to bridge into your talk on storage migrations.
Okay. Thanks, Dan. Thanks for the introduction.
Absolutely.
Yeah, runtime engineering. So Substrate is this complex beast and with lots of moving parts, and we have this nice layer image, and like at the bottom is stuff like networking and the database and so on, and that sort of the node consists of these parts and like how they interact and so on, and lots of important things like the consensus algorithm and so on. And then there is a virtual machine in the node, and on that virtual machine runs the runtime. And I'm a runtime engineer because my job is building, but also helping others build in the ecosystem, building runtimes for blockchains. And the idea behind Substrate is that, like, yes, you can change the node, and that's often what you want to do if you want to add an extra CLI parameter, a command line parameter. But one of the key things is you want to program your blockchain, and you do that by creating the runtime that does what your blockchain is meant to do. And so the runtime is the state transition function of your blockchain. And so one of the things that I've been working on a bunch this year is storage migrations. So I helped the Edgeware team with their storage migration, which was quite a big one, included quite a lot of individual storage migrations. And I sort of took the topic as, I don't know, it's my baby, or I don't know, the thing I want to push forward, because I think we can do a better job with runtime migrations. Like, I think it's difficult, and like sometimes they are just incredibly complex, but I hope that we can make the easy ones easier and more automatic, and improve testing and so on.
Can you give a little introduction into what Edgeware is, and maybe why that was a complex storage migration?
So Edgeware are living on the edge. It's right there in the name. So they were I don't want to say anything wrong, but I think they were the second team to launch a chain based on Substrate, like a runtime, a production chain, in, I think, January this year, January 2020. And so their chain is focused on sort of governance and collaboratively shaping the blockchain together with the community on the one hand, and then on the other hand, they want to provide a smart contract platform for sort of people to do whatever they want to do with smart contracts, including governance, testing, and DAOs and so on. That's sort of my understanding of Edgeware. And
is there any particular reason that you can identify that they had a relatively complex upgrade path?
So there was a lot of development happening on Substrate leading up to the 2.0 release that was not too long ago. And so a lot of development happened in the last year on the one hand, and also it included a bunch of changes to the framework for building runtimes, and also just to the individual palettes that are part of sort of the Kusama and Substrate, and also Edgeware. And like Parity is this like big organization with lots of engineers building this framework at this like great pace, and sort of we were iterating quickly on and also with Kusama. And so Kusama got all of these upgrades, and like Edgeware would have needed to sort of keep pace in a sense and like build an upgrade any time that Kusama did. And I think that was a hard time to keep that pace, was a difficult thing to do. And so so at some points they were sort of a little bit out of sync in terms of runtime upgrades. And then as soon as you are out of sync, it gets a little bit more difficult because the migrations sort of depend on the state, but also on sort of the current code of Substrate. And so old migrations were removed because like you don't want to keep all of them around. You want to sort of remove the ones that you don't need anymore. But then Edgeware needed them because they were on a different runtime state. And so that combination of rapid change in the code combined with like a bigger gap in the runtime migrations led to this complex migration.
Yep. So what I'm hearing is it wasn't necessarily anything unique to the Edgeware use case. It was more an artifact that they were building on unreleased versions of Substrate, known unstable versions of Substrate, and then some tech debt accrued, which happens when you're building on bleeding edge. That makes a lot of sense. Okay, cool. Thanks. I appreciate that explanation. I also see that someone has already used the Ask a Question box, which I really appreciate. I forgot to mention that. So if you have a question for Alex, please definitely use the Ask a Question box. Continue to use the troll box, as we call it, the chat for chatter, but serious questions in the question box. So let's see what Joshi has to say. He says, I remember you asking about migration code that was put in Substrate and then removed. Did Edgeware have to update to each commit in Substrate's history? And then he says kind of, oh, yeah, you already addressed that, but maybe we can just clarify it for everyone else.
Yeah, so there are two rough strategies that you can follow when you want to upgrade. One is to sort of go each step of the way, and some people recommended this. Drew, who I worked with at Edgeware, and I decided that it wasn't quite realistic because of the time that it takes to get a proposal through on the runtime. So for every upgrade that you need to do, you sort of have this period where, right, you need to decide on the runtime upgrade and so on the proposal. And so you would it would be difficult to sort of catch up in a sense if we did all of the migrations one after the other. And so what we decided to do instead was to sort of take the migrations from the history, check out the old states, and sort of take the code and just basically just copy paste it, adjust it to the current types and also to Edgeware situation to some extent. Like at some point, I think we just set a default value because that was good enough and so on. So we adjusted the migration and sort of built one big runtime migration that Edgeware could run to sort of catch up all at once, in a sense.
Yeah, and it sounds like maybe that was kind of an artifact of the fact that they were a live chain. If they had been in more of a proof of authority kind of like centralized model, it would have been potentially a lot easier to push those upgrades through iteratively, maybe. So yeah, it's the migrations really, the flavor of the migration really depends on the chain that the migration is happening on.
I would say so, yeah.
Yeah. So that's a really great introduction. If anyone has any other questions about kind of what we're talking about here, please continue to use the Ask a Question box. But yeah, I think let's start talking about storage migrations. I'm ready to learn a little bit more. I'll probably take myself off the screen, but I'll still be here maybe asking questions every once in a while.
Cool.
So yeah, take it away, Alex.
All right, cool. So I have a small presentation. It's not very fancy. It's just a matter of tracking the talking points, so to speak. But yeah, so the aim for today is to present what my take on runtime migration best practices, or with the subtitle, How to Avoid Mangling Your Storage on Runtime Upgrades. Which is sort of the risk that we're trying to manage here, to avoid. So to sort of set the context, we want to do a quick recap on like, oh, why do we need runtime migrations? Why is this a topic at all, right? And for that, I would go to the combination of what is a blockchain on the one hand, and on the other hand, what is particular or unique about substrate-based blockchains. And the unique thing is the forkless runtime upgrade that we already mentioned earlier, right? So in a normal blockchain, you have sort of these blocks, right? 41, 42, 43, and you have a header and a body, and then some state transition function that will, transform the state from block 41 to block 42. And this is all great. But in Substrate, the state transition function is the runtime, right? It's this programmable thing that can be changed. And so what can happen is that in the body of a block, a new runtime, a new state transition function is set. And then the state transition will change, right? The state transition function will change, and now the block production will be different, right? So before we have some, like I made up some schema, right? We have something in storage, and it's a unsigned 32-bit integer, and then a forkless upgrade happens, and we have a different schema. Right? We have the second version of the runtime, and it now expects some struct to be in storage, some structured data, right? So with this change, so a forkless runtime upgrade can change or will change the schema that the runtime expects the storage to keep. And so...
Can I just maybe like chime in with a little analogy? So totally clear, like what a runtime is, a state transition function. It's a state machine or a state system, So when I think of this in my head, I just think of like this board that's in front of me that has like all these little levers that I can turn, and set them up in different ways. And then like, maybe like an abacus or something, like all the different little things on an abacus can be in certain positions. And so you have that ability to move things around and represent different states. And so what a runtime upgrade is now it's like, maybe there's another row on your abacus, or maybe each one of those rows has a different number of little gadgets associated with it. So it's kind of like changing the parameters of this state machine, changing the realm of possibilities that you can configure.
Yep. Yeah, exactly. Yeah, a metaphor I like to use is a blockchain is as a big spreadsheet, right? Except that instead of a normal spreadsheet, it's a spreadsheet where we agree on what values are in all the cells of the spreadsheet. And then one of the values in the spreadsheet, in the case of Substrate, is what code is used to, sorry, my screen turned off. What code is used to run the spreadsheet software, so to speak, to run the interface. But yeah, great idea. Thank you, Dan. So what does this look like in a little bit more detail? Now we're sort of jumping in a bit more detail. So this is a block, and sort of it's a little bit here. It's not very accurate because I'm sort of merging the block execution with the block as a piece of data, right? And that's always a tricky thing, or a thing to keep in mind. There's, on the one hand, there's the block as a piece of data, and then there is the block execution as in like an order of operations. So here we're looking more at the block as an order of operations, right? And so the first thing that runs is on initialize. Some values are initialized, like maybe the timestamp is set. They're like in substrate-based runtimes, there's usually a timestamp. Or the block number itself, actually, I think is set, and some other data. And then if we have a Forkless runtime upgrade happening soon, then a set code might be the second thing that's in there. And then maybe some other extrinsic. So it's extrinsics being the name for some operation that can be executed. So one of those extrinsics is the set code one, and what it will do is it will change the code of the runtime. And so here in this particular block on the left side, we are still in the old version of the runtime, for example, version 1, right? And now that we've set the code, the runtime will be changed for the next block. So the next block execution will look more like the one on the right, where the on runtime upgrade callback will be executed, and then the rest of the block with the new code. So this is sort of where the magic happens, right? The runtime storage migration, and this is sort of where it happens, and also why it's necessary, right? Because the code in on initialize and in the extrinsics that will be executed in this new code will already assume the runtime version 2. It will assume the new schema. And so if it assumes the new schema, but the data is not in the right format, then it will not work, right? You will get errors. And we want to avoid that. So that's why we will, the very first thing that we will do before the new runtime gets to run in its normal way is we will run a storage migration in order to migrate the schema, and sometimes also the data. Sometimes so it's it migrates the schema and the data at the same time.
So one thing that we talk about in programming is like this idea of like a hook or something. And so this is like a hook that occurs on a storage migration and gives you the opportunity to, you know, let's say that you added an extra row and added extra gadgets to your abacus. Now it all means different things, you know, because there's different numbers. And so this is your chance before the new state transitions start to be executed to kind of realign everything on that abacus and make sure it all makes sense and it maps one-to-one to how you want it to look.
Mm-hmm. Exactly. Cool. So this would be the recap for the context. Is there any confusion left? Any questions? I think now would be a good time if
there haven't been any questions popping up. It's only been me with my little comments from the peanut gallery. Everything's crystal clear.
Nice. Okay, cool. So this is the context. So now we want to sort of go into the migration process. So I think part of the best practices for me in my head is that you want to at least quickly think about all steps in the migration process and check what you need to do for each. So I would sort of define the migration process as these 5 steps of 1, preparation, sort of figuring out what you even need to do. 2, writing migrations that might be necessary. 3, creating the runtime upgrade that will run the actual migration. 4, testing that your runtime migration doesn't mangle your storage and leaves it in the right state. And then 5, execution, where you actually execute the migration, the runtime migration. And of course, this is just a rough thing. Like while writing a migration, you might already want to be doing some unit testing and so on, right? This is just for clarity, and so I can talk about it this way. But of course, it can be a little bit intertwined. Or you might be creating the runtime upgrade and notice that a migration is missing, and so you go back and write a migration or something.
Alex, we actually do have a question about the context. Let me just go ahead and read it here. Could you give some context? What problem is solved and when, kind of what's the big picture? So just to kind of step back, the thing that Substrate makes possible, or one of the really key things that Substrate makes possible, is this ability to perform a runtime upgrade. This is a novel capability that doesn't really exist in other blockchain frameworks. And so what that means is you can add rows and columns to your spreadsheet, to your abacus, however you want to think about it. But this power, this capability, introduces complexity, because now you have to let the state machine, you have to make sure that the state machine is reconfigured per the upgrade. Any additions to that to kind of set the stage, Alex?
I'm not quite sure I understood the question. Could you give some what problem it solves and when? Big picture. Thanks for the video. So I think you already said it nicely, that sort of the fundamental thing that the Forkless runtime upgrade addresses is that what your blockchain needs to do changes over time, right? Like it's like if you look at other blockchains like Ethereum or Bitcoin, you will see that they change over time. And the Forkless runtime upgrade, well, it's already in the name, right? What it allows you to do is it allows you to change your blockchain without needing to sort of coordinate between all nodes, between all people in the network when you want to change something, some logic in your runtime.
Yep. So Tomas, it seems like he's kind of integrating what we're saying. He says, okay, I see how to migrate data from one spreadsheet to a new one. So yeah, in a state machine, you need to kind of define an order of operations, a way that things proceed, some kind of deterministic flow that you can follow so that you as the developer can make sure that things work properly. So if we're kind of like continuing this analogy, the capability that we have here is that we can kind of go into the spreadsheet and like add all of these new formulas and everything, but we do that before we're actually able to move the data around. So then the order of operations is kind of first we add the new formulas and all that kind of stuff, and then the migration, what Alex is going to talk about, is this kind of step that occurs after that, where we maybe go in and move things around on the spreadsheet itself so that the right pieces of data line up with the right formulas. And so that's just the order of operations on a Substrate chain. So the topic needs to be complex, extra complex. It is pretty complex. I mean, blockchains are kind of complex. And then, as Alex and I have said, this is something that is necessarily going to be different for each and every chain, each and every situation. So it's hard to kind of give you simple answers. Anything else to add to that, Alex? Oh, okay. No, we do have another question from Jesse. I understand why I would need to upgrade a palette I changed the storage in, but are there times when I have to worry about the migration of the external palettes? So would Jesse ever have to worry about a migration that occurs in the balances palette, or should that be handled for him by the developers of the balances palette?
So the unfortunate answer is yes. you need to worry about the migration of external palettes. The good news is that you don't always need to care a lot, so to speak. So if the migration defined in the balances palette is sort of written in a generic way and is a simple migration, then that doesn't have sort of any or very few cross-cutting concerns, then you might not have to worry much about it. So it sort of depends on how paranoid you want to be about your runtime upgrades, right? In theory, you could say like, I trust all the people that write palettes for me, and I just wire them together in my runtime, and then those will execute, and everything will be fine, and I'll run with it. And I think in practice, I think you don't want to do that for something that has a lot of value locked behind it, right? You want to check. But a lot of the time, you will not need to change it, I would say, right? You will just take like, hey, this is the migration introduced in the palette. Is it compatible with my runtime? Yes, it seems so. Cool, let's run it. And then you will probably still want to just do an integration test, like, there was a balances migration. Well, then let's try interacting with the balances module after the migration. Does it still work? Yes, okay, cool. And then you might not need to have a huge process and a huge involved project about it. But I think you do need to worry a little bit about it.
Yeah, I think, kind of just what I'm hearing is like the answer is it depends, as it would always be with storage upgrades, storage migrations, runtime upgrades, excuse me. And then I think the other thing that I'm hearing is deploying changes to a blockchain is not something that should ever be taken lightly. Just like you would hope and think that your bank does not ever take deploying any kind of changes lightly, even if they're just upgrading a small, let's say, NPM dependency. You really hope that they have a staging environment where they test that and they make sure that it works. And so that is, I think, basically what I'm hearing from you here is you want to look at this a similar way.
Yes, yeah. For me, a lot of this is very similar conceptually to a database migration, right? You have some production database somewhere, for example, a bank, right? It has the production database with the accounts and so on, and there's like a lot of value that depends on the integrity of the data, and now you want to change the code that interacts with the database, and for that reason, you want to change the database schema, or you want to adjust some values in the database. And so what you do is you run a test of that migration, see whether it works, have a staging, as you said, and see that it all works fine, and then you do the migration to change the production use.
Yeah, and I think a database migration is a great analogy, because if we have other software engineers in the audience that have worked in enterprise software companies, and you've ever had to do a database migration, do you feel that anxiety that just saying the word database migration causes? I mean, it's not ever something that should be taken lightly. It's kind of like you're going in and manually mucking about in these things that you only ever trust a computer to muck about in. And so it should always be taken extremely seriously. Yeah. Yep. Okay, let's finish answering Jesse's question. We have another one here. I think we may have kind of answered it. Does it have any security risk? Is there any possibilities for hackers to inject new function into the runtime? That's an interesting question. Do you want to take that one, Alex?
Yeah, sure. Let's quickly take it. So yes and no. So if you run a runtime upgrade that someone else gives to you, then of course you're susceptible to them injecting logic in that runtime upgrade that you don't want there. So what you want to avoid is just taking some WASM blob in Substrate, right? It's WASM. So some WebAssembly blob and running a runtime upgrade with it on your blockchain. Apart from that, so that's what you need to avoid mostly. So what you want to do is you want to have some sort of reproducible process to build the runtime so that you can say like, look, this is the code. it reproducibly produces this kind of WASM, this kind of instruction blob, and then people can check and verify, right? And then you will, sorry. Okay, then you will register it with the runtime, right? And then people can cross-check, like, oh yeah, this is actually the right one, and right, and it will go through the governance process that you have on your chain, whatever that might be.
Just to kind of continue with the, your bank deploying changes. Yes, when your bank deploys changes, that would be an opportunity for a security risk to get introduced. So, for instance, if it is a change to some NPM package, if they haven't done their due diligence and audited that NPM package, it's very, very possible that that would be an opportunity for some security flaw to be injected. But Substrate provides all the tools that you need to protect yourself against that. So in particular, I've shared this link to the SR tool, which is the Substrate Runtime tool, I think, which does exactly what Alex suggested. It allows you to take the source code of a runtime so you can look at exactly what that runtime is going to look like, understand everything that it does, and then compare that with the actual WASM blob that a runtime upgrade specifies. So there is a security risk. It's important to know how to avoid those security risks, and in a lot of ways, that's what we're here to talk about today.
And then there is some risk, and I'm not sure that falls on the security risk, just of the runtime upgrade being faulty, right? And if it introduces something that will, I don't know, like if it wipes the balances on the chain, then of course that's a problem. And so if that falls under your definition of security risk, then that will be another risk.
Well, yeah, I mean, I would like from my point of view, like you're kind of given the same level of flexibility that you have in the chain spec file, where you're kind of just like setting storage values. So like I could imagine something that someone could do on a runtime upgrade, on a migration, is just set their balance to the maximum possible number of tokens or something like that. And that could potentially be a huge security upgrade if you have a staking chain or something like that. So yeah, you need, this is very serious stuff, and that's why Alex is here to talk about it and make sure we all understand it. So let's finish answering that question, and Alex, I'll hand it back over to you. Thank you for those great answers.
No worries. Thanks for the questions. So we looked at when this stuff happens, what the context is, why are we doing all of this, and we're now progressing to going into the process. So what does preparation mean? What do I mean with that? What it basically means, and here the fidelity of my slides will go down, I'm very sorry, is that you want to check which code do you need to include, which migrations do you need to include, and there is a listing, there's a link that is not, a very, let's say, technical look at what has changed, right? Like you can look for the Substrate palettes, you can see all the runtime migration relevant changes that have happened since roughly the start of this year, right? And you can see, redesign democracy palette. So if you include the democracy palette in your runtime, and your runtime state was your runtime was started before 21st of March, right, and has not been upgraded since, then this will be a relevant migration for you, right? And you will need to include it. If you include other external palettes that are not written by Parity, for example, the ORML, Open Runtime Module Library, I think it's called, then you will need to check when they have included migrations, right? And if your version is older than the last migration and you want to upgrade to the new version, then you will need to include that. And this is sort of where Jesse's question becomes relevant, right? you need to, so the last migration that's current, right? So from the last version to the current version, that will likely be included, right? Like here, move proxies migration. The move proxies migration will still be included, but other migrations might have already been removed because they're out of date, right? And this is, we also flag these PRs that remove the runtime upgrades. So you might have to reintroduce them and get this sort of stuff together. This is unfortunately for now, if you do not follow the Kusama sort of roughly the Kusama upgrade schedule, this is something that you will have to do if you upgrade less frequently.
Alex, can I just kind of chime in with a little bit about removing runtime upgrades? So we talked about having hooks that you can put into the code. And so it's code that's there that is a hook that any time that something happens, this code is going to run. So you can imagine that these runtime upgrade hooks, as we said, they're very specific to one point in time, one scenario. And so part of using them is removing them. Once that hook has run in that given scenario and changed things around, you don't ever want it to run again because it's already done its work. And now it's going to be, as I said, kind of mucking about, doing things that you told it to do, but that it has no business doing anymore. And so, just kind of want to drive that home. And again, if you've done a database migration, this may be an idea that's kind of familiar to you. It's certainly an idea that I'm familiar with, but it's an important one to keep in mind.
Mm-hmm. There will actually be another best practice that addresses something like this as well. But yes, so we want to remove them because they're one-time things, so you might have to dig a little bit through the history if you want to migrate from a very old state. That is the preparation, figuring out which migrations do I need to include, and that depends on which version you're migrating from, what logic is included in your chain, and which version you're migrating to. Then the second step is writing migrations. So I want to sort of use this moment to sort of advocate for a vision that I have for runtime migrations that I'm trying to spread, which is that we want to make sure that migrations are correct, documented, discoverable, and reusable. And this means, if we want them to be correct, we want them to be testable, and we want them to be composable. So we want to be able to determine whether they ran successfully, and we want to be able to run one after the other without corrupting state. And then documented is fairly self-explanatory, right? We want to sort of have assumptions listed in there if possible, or at least in the pull request or whatever, somewhere we want the assumptions listed, what they assume, and being discoverable means that you can actually find it. That's part of why I created this runtime migration label, right? So that you can find the migrations. And then reusable, right? This is, again, sort of harping back to Jesse's question. If the balances palette changes some internal implementation detail, right, and it shifts from, I don't know, some internal value from U32 to U64, then that shouldn't impact the rest of your runtime necessarily, right? It should just work and it should just run, and so that's a part of the vision, I think, for me, for these migrations. So with the sort of broad overview vision, I want to go to actual things that, like practical things that you can and should do when writing migrations. And one of the key ones here is storage version checks, and it addresses exactly the point that Dan already mentioned, which is we want to execute migrations exactly once. Let's see where we have the example for this. Let's dive into some code. Is this the one? Sorry.
Don't forget to make the text a little bit larger. Yeah. Thank you, Alex.
Very good point. Yeah, it was this one. Ooh, okay. This is readable?
Yes, looks great. Thank you.
Cool. All right. GitHub does this thing where it hides all the interesting files. All right. So what we want to do is we should check the version. And for this, what the usual practice that we've sort of developed is that we just store a version in storage, right? So this palette storage version function will access the storage, and then you can, this is an enum that contains some version, and then you can compare, okay, which version is the storage at, the data at. And then if my runtime upgrade has a more recent version, so here we're upgrading from version 1 to version 2, right? And then you can store, once you've done the migration, you can store the new version, and then with this version check, the thing that Dan was talking about will be avoided, right? It will only be run once, even if you repeatedly upgrade the chain. And I think this is very important because if they run several times, it can break things.
Yep, and this is exactly how I've seen it work in database migrations before. And I'm just going to drop a link to one migration framework that I've used in the past that I think does basically exactly this. The migration framework creates a special table for you that often just has a single cell in it that tells this tool what the state of the database is, and the tool maintains that state. It's a very, very common and good way of approaching the problem. We do have a question, so let's take a look at this if you don't mind. What happens if the runtime upgrade changes the consensus or the block import logic? The connected nodes could get lost in reorgs, even though the blockchain state is correct. Is there any way to assure that the consensus still works after the upgrade?
So this depends on what you mean with ensure and getting lost. So I'm not an expert on consensus or the block import, so I cannot give you very deep details there. What I do know is the following. For every block, even if we have several branches and there are reorgs, for every block, there is a defined runtime, which is part of the runtime state, that specifies the state transition logic. So even if there are reorgs, like the transition function is deterministic and is included in the state. So the node will always know how to transition the state. And then there might be branches, and then it might take a while for those branches to collapse and to have a final chain. And this can be complicated or whatever. And then you as a user of the blockchain might need to wait for that finality in order to be able to determine the correct state. Yeah, right. And that's another very good point that Joshi is making there in the comments, that some parts of all of this machinery is outside of the runtime. So particular data that is needed for the consensus and so on lives in the runtime. So for example, the authority set, as far as I know, for Babe and Grandpa, the block production and block finality algorithms used in Substrate, they are in the runtime, but a lot of the logic lives outside. And this, very good point. Thanks, Joshi. So, did we answer that question? Cool. All right. Do runtime upgrades ever have issues with fitting into a block? Do you just want to take that question, Dan?
Yeah, sure. I think I gave a little answer there in the comments. So I said, yes, this is why we have the pseudo unchecked wait variant, as well as the ability to schedule upgrades. So these, I think, kind of allow you to make sure that a runtime upgrade is the only thing in a block. But I don't know if that gets all the way to the answer that Jesse is looking for, which what happens if it is the only thing in the block, but it just happens to take 8 seconds to do it, and you have a block time of 6 seconds? Is what happens in that case?
The block time just increases. I actually had a question like this in the builders chat recently. And so the way that I relate to block times, and feel free to correct me, anyone, if you know better, is the block time is meant for predictability in general for the chain. It's not that you don't want to build too many things that rely on the block time being kept every time, right? Something can take a little bit longer. It's just the block time is meant as a thing to sort of give rough predictability over time. So a runtime upgrade is not something that you do every block. It's not even something that you do every day, right? It's something that you do, I don't know, once every 2 weeks or every 4 weeks. And it's not a big deal if there is a block every 4 weeks that is 8 seconds instead of 6. So, yeah.
So yeah, maybe better to think of that, and maybe even now as I'm thinking, I may want to propose that we change this, that it's like target block time as opposed to block time, because it's not an invariant, it's a target. And so what is an invariant is the maximum weight that can fit into a block. And so there's assurances around that. There are escape hatches that allow you to do things like runtime upgrades. But yeah, that's very interesting. Thanks for illuminating that. I'm going to go ahead and click done answering and let you take it away, Alex.
Cool. All right. So I wanted to note one thing on the versions, and this is a little bit more of a teaser. So we've we saw this pattern of like, okay, we store this the version in storage, but like doing this by hand is a little bit cumbersome and introduces some friction when writing migrations. So there was a pull request, or like there was some work that we did. Thank you, Basti, for implementing this. That adds a palette version to every palette that is written with the framework. So that it automatically, the idea is to automatically take the crate version of the Rust crate that your palette is in and put that into storage, and then you can just check the palette version when you're migrating, be like, oh, is this version 1.5? Well, then I want to migrate to version 2.0 and to reduce the friction for doing this kind of versioning checks when migrating. But this is just a teaser. This is not released yet. I think I've heard that Substrate will be released, the new version will be released soon, so hopefully we will all be available to use this soon. But yeah, just a teaser. Okay. So another thing that you will want to do is you will want to include deprecated types to migrate from. So here I want to sort of quickly go back to a thing that I showed earlier, which is this one. And this distinction now becomes relevant. The runtime storage migration happens inside of the new runtime in the new block, right? So it's not that there is some magical time in between the blocks when the migration runs. It's part of the new block production. So we have access to all the new types because we're in the new runtime, but the old ones were gone, right? I mean, they might still be there because they are the same, right? If they're the same before and after, it doesn't matter. But they might potentially be gone because we switched the runtime. And for this reason, we want to potentially include deprecated types. So a pattern that I've identified and used is to have these small modules with deprecated storage items that define the storage item as it was before in the new runtime, so that you can still access it. And then if you have this, like for example, next enum set, let's see whether we're accessing it here. Yeah, here enum set, right? We can access it. We can still access the enum set and take out the data, for example. and then use it for the migration, right? We sort of use the old part of the old schema, or we use the old schema to access the data, remove it, right? Remove the item from storage, and then we can transform it into the current format and then insert it. So,
Alex, what's the name of the function that you're in right here?
Oh, this is the migration. This is migration function. Yeah.
Now, is this a migration function because the name begins with migrate? Is that a convention, or do you somehow configure this to be a migration function?
That's a very good question. So this is my personal convention. This is not necessary. So as soon as this actually brings us to the next recommendation that I would give for best practices. I would say it's a good practice to have one migration within one function, so that it's like encapsulated. So the migration is run on runtime upgrade. Actually, if I search for it, it will probably be here. Yeah, there we go. Right? So how the migration actually happens is that you include your migration function in the on runtime upgrade callback in the hook. Right? So this is the here the indices palette that we're in, and here we are in the let's give you a little bit of context. We are in the declare module macro, right, which is used to define the dispatchables that we have here, right? The extrinsics that we can compute. So here it would be claim, for example, is one, and then here's also where we define the hooks, like on runtime upgrade.
Okay, so I just am pulling a few things together here. On runtime upgrade, that is convention. If there is, go ahead.
So convention, I mean, so the macro declare module, the declare module macro, you could say it has the convention. I don't know, like part of the macro is that it detects if you have a function called on runtime upgrade. And if you do, then it will generate some code that calls the on runtime upgrade function when there is a runtime.
I would call that like a type of convention. To me, it comes across as like magic. Like if you define in decal module a function with this signature, that function name, that return type, then it will be run in this magic where the magic happens, as you said before. And so now what you've done as part of your vision is you've in a separate crate, it looks like, in a separate palette, maybe even a separate module is where you have actually written that migration. Now let me ask, why don't you just write the code right there in the on runtime upgrade? What is the purpose of having that function just call one other function?
So yeah, this is it's sort of part of the vision that I have for the best practices. This makes it easier. Like I could here after this function, I could have a second migration. I could just run that as well, right? I could do migration, migrate enum set, and then I have migration, migrate claims or whatever, right? And so in runtime upgrade, I would very clearly see like this is the migration that's running, and then on the other hand, with the function, right, it's like it has some name that I can identify, and then I have some function that I can test. That's the other thing that I like about this is, right, I can, now that I have this separate function, I could, like here in this case, it's not the case, but I could easily add some testing functions to this module that tests whether this does the right thing. And I think that like...
And that capability doesn't exist as easily with just the on runtime upgrade function itself.
Yeah. I think it's... Yeah.
And then I had one other question. I think I forgot. Why is the migration function, you said it's, okay, I think I lost it. I'll let you continue.
Okay. All right. Okay. Cool. All right. So we have this again.
I remember. It's really weird to me that the on runtime upgrade is declared in decal module, because when I think of it, decal module is where you declare dispatchables. So why are we putting on runtime upgrade? Like, first of all, I noticed that this isn't a public function. It doesn't return a dispatch result like the other things in decal module. So what is the reason for it going? Because you can't invoke it like a transaction, right? It is not a dispatchable, or is it?
Yeah, I think it's not a dispatchable. I wonder whether this is a historic reason, actually. I think I'm going to let me note that question down and get back.
Yeah, that's totally cool. That's an implementation detail, and I don't want to derail the conversation based on an implementation detail. So we'll answer that in the seminar chat on Element.
Yeah, yeah. And my guess would be that the reason is historical. That it might be worth it to be like, oh, declare hooks or something, to have a separate macro, right, where you can have these hooks. That could be a viable thing. I think another practical reason why this would be desirable potentially is that you want easy access to the module in the hooks. Potentially, but that should be that should be possible outside. Yeah, my guess is that it's historical. Okay, so let me get back to the best practices. So you might want to include the deprecated types. This is not strictly necessary. Let me show you the alternative that's also possible, if maybe slightly less desirable from my perspective. And it's stuff like this, where you access the old storage based on you knowing where it is, right? So there's something called the storage key iterator, and you can specify some types that it will use to iterate over the storage. And so based on you knowing what the old schema is, right, you can choose the right types and the right sort of name for the storage entry, and then it will iterate over the storage. And that's also a possible way of accessing the old schema and sort of getting that data out and using it for migration. So this is the one that I wanted to mention because we already discussed it. Basically, I think it's good to make migrations reusable. So, for example, extracting them out into a function like I just showed with the migrate enum set, I think makes it easier to test and modularizes it. And maybe even makes it easier to find again if someone wants to reuse it, and so on and so forth. So I would recommend that. And then another thing that I would definitely recommend is to include logging to help with integration testing. So yes, you want to unit test, but also you want to do integration testing, and just have the runtime upgrade run with your node, and then it's good to be able to see whether the migration was run and to see whether there were maybe any errors or something. And I think that's definitely a best practice I recommend. Okay, reusability. Let's get to the runtime upgrade. So now we have this list of migrations that we want to run. We know what migrations we'll be running. They're all there, right? Either as dependencies because the balances palette has a migration included, or because we wrote one. And now we want to run build the runtime upgrade that will actually execute the migration. And here I want to know just a facility that is very, very useful and that you will need if you need to change the ordering. So the thing to note is that here, okay, yeah, sorry, I need to give more context. So executive handles the dispatch to the various modules. So it sort of determines how things are executed. And it includes this all modules type that is generated by the macros that sort of generate the runtime. And this all modules has a quirk currently. This is sort of, I would say, in the works to change this potentially in the future, but it's good to be aware of if you have a complicated migration. And that is the following. I just want to check my notes. So they are executed in reverse order of declaration. What does that mean? Come on. There we go. So this is from the Edgeware migration that I mentioned earlier in the introduction. And this is the construct runtime call. So this call will actually sort of wire everything together. And these are all the palettes, right? This is the system, frame system, and this is palette utility, and so on and so forth. Staking, democracy. And so what all modules, this type, and thus the runtime migrations will do is they will execute in reverse order. So they will start with treasury reward, then go for voting, then go for signaling, multisig, and so on and so forth. And usually, if the migrations are simple, this will not matter. But if the migrations have dependencies between them, because the palettes have dependencies between them, this becomes very relevant. And you might want to define a custom order of runtime upgrades. And this happened for the Edgeware migration, which is why I'm showing it here. There was one fairly complicated migration, which was the hasher migration, where the hashing was changed, and the default hashing was changed in the runtime for Substrate runtimes in Substrate. So this hashing, like all the code before expected the old hashing, and all the code afterwards expected the new hashing. And so old migrations and new migrations were not really compatible because they expected different hashers to be there. And so that's why I ran the old migrations that assumed the old hashers first, then ran the accounts migration, which ran the hasher migration, and then I would run all the other ones. And you can do this via this custom migration, custom on runtime upgrade that you can define. So you can take any struct, and you can implement on runtime upgrade, which is a trait for it, and define your own on runtime upgrade function. And you can pass this to executive here as the last type parameter. And if you do this, then these migrations will be run first. And this sort of execution is very, very in-depth. So I'm sorry if I'm boring a few people. But for people that will run into this, this is like this is a lifesaver, because otherwise you cannot do the migration that needs to happen for your runtime.
Yeah, just basically what I'm hearing is we've talked a lot about the fact that each runtime upgrade is very unique, very distinct, depending on the situation. And so we provide capabilities to do things in different ways, give you more control if you need it. And so in the simple case, you don't need to use this custom type of runtime upgrade, but if you have a more complex case, then we give you the opportunity to do things in a more custom way.
Yep, exactly. And I just wanted to note that. That allows you to define the runtime upgrade and the included migrations in just the way that you need it. And then you can switch over to testing. And for this, there's actually two small demos. Yeah, maybe we have enough time for both of them. We'll have to see. Two small demos to show how to test runtime migrations. I want to note that this part of the story is still developing. So there is a tool called Substrate Test Runner that's still in development at Parity, where we're trying to make this sort of testing better. There is the possibility to do unit testing just as a normal part of a palette. You can do unit testing. That's possible. That's already there. And then there are these two sort of ways of doing testing with real state, because for migrations you will want to have the state of your production chain that you will actually be migrating for the test, and this is somewhat of a challenge, and we are working on it. That's all I want to say. I think we'll start with the unit-like tests, where we will use a tool called remote externalities that Kian has built. Thank you, Kian, for this this thing that you've built, and I want to show it off with a migration that he's currently working on to showcase how this kind of thing can work. Let me check. Sorry, that was the wrong code that I had opened there.
Alex, will you be able to share the code that you're going to be demoing as part of this?
Yes, I can share it. I want to note that this is a little bit brittle, so this is a little bit tricky for people to I hope that they can just run it, but because this takes the current state of Kusama, if this current state of Kusama changes, if the runtime upgrade that we're testing right now is included in the chain, then it will not work anymore, right? So there is a sort of ephemerality to this thing that I'm demoing right now. Of course, the general technique always generally works, but it's just that this has sort of an expiry date.
So, yeah, the way that I always cover this is for educational purposes only. Don't use this in production. This is just to kind of show you how things work. Educational purposes only. Covers all sins.
Nice. It's for education. Okay. All right. I found the. Let me increase the size a little bit. Let's do a little bit of context first. So we are in this is called the Substrate Debug Kit repo. This is sort of a collection of tools, and it includes the remote externalities that I mentioned, and then it includes. Right now, it includes this particular usage of the remote externalities to test a migration for the fragment election crate and palette that will be coming soon. And so it includes a main. It's a sort of fairly simple program, just a few hundred, 150 lines of code, and maybe let me start from the core thing that is interesting about it, that it does, and then sort of give the context later on. So here you can see migrate to recorded deposit. So this calls the migration function from the fragment elections palette in this sort of piece of test code, so to speak. And before we do that migration, we iterate through the storage and collect a bunch of data. And then we, after the migration is run through, we go through that collected data and check the new state, whether it is what we expect. And then we check some other part of the runtime, namely the accounts, whether they fulfill some fulfill some invariant that we would like to uphold, right? So what this allows us to do is that we can check this sort of invariant about our migration. And in this particular case, actually, we could have also run this migration afterwards, and then checked some other stuff there. Sorry, I'm getting a little confused here. So part of the thing, the accounts, we could have also checked beforehand, and that would have been just the same because this migration does not touch the accounts. But the other part we couldn't have. So I guess this part could have happened beforehand, just to be clear for voter and voters, etc. Just to avoid confusion. So we can check certain invariants about our migration code, and then what we can also do is we can check the new state after the migration code has run through. That's what I wanted to say. What's interesting about this, why I'm demoing this code, is that we found that this invariant was violated. So we found that an assumption that was made by the migration code was actually not quite true. And this is one of the things where this tool can be incredibly useful. Okay, there we go.
Alex, can I ask a question? So
yes.
I understand definitely what you're talking about. You want to be doing checks possibly before and after the migration, maybe even in some ways during the migration. So I see that you have there, like on line 137, you have some assert equal statements that's going to panic if that assertion is violated, correct? And so what would happen if that is the case? Does the migration roll back, or is things left in an inconsistent state?
Right, and now we come to the context of like, what are we even doing here, and why can we even do the stuff that we can? And the reason is this execute with and this whole like externalities thing. So what this does is the following: it will download the given modules from the given URI at a specific block state and execute your code, our code, in that context. So it will go to Kusama RPC and download the modules, and then it will provision an in-memory representation of the blockchain in some sense. So it will basically provide an environment that's very, very similar to a testing environment, except that it draws its data from the source that we've given it. So what will happen on this assert is that this particular program will panic and go out. But because we were in this like created environment, in this created testing environment, nothing about the source has changed.
Right. Okay, that makes sense. So basically, what I'm hearing, and please correct me if I'm wrong, is that when this happens in real life, IRL, then things would be left in a really bad, inconsistent state. And so going back to all the things that we talked about, you want to make sure that you test things. And so this tool allows you to test things in a safe place and give you a place where if things go wrong, it doesn't matter, and allow you to iterate on that. And that way you can basically run it over and over again and make sure that it's going to work when you go and run it in the real world. Is that correct?
I think so. And yet the thing that I'm just thinking of now is, so this is an RPC connection, and I wonder whether it does whether if we do a set. The migration does a changes the storage, but it doesn't change the actual Kusama storage. It changes the local representation that we've downloaded. So yeah, right. So it's the sandbox environment. Yeah.
Yep. Very nice.
Yep. this also provides us this also shows a little bit the drawback with this method. So we need to specify our sandbox environment, right? We need to know what kind of state our migration will be touching. Of course, we can also just download all the palettes that we have in our blockchain. And then I guess that's less the case. But then also the test will take longer because we will be downloading the whole data of the blockchain at every point that we run this code. So there is some sort of trade-off here. And then in order to be able to access this stuff that's shown here, there is some sort of, I would say, boilerplate necessary. We need to define some mock runtime object in order to be able to do the kind of state access that we're doing. And this is avoidable if we include a dependency on the actual runtime, but that has its own problems and pitfalls, because then the whole runtime needs to be compiled, and that makes it slow. There is some, what I want to say is there is some complexity left here that where we need to still work on it and improve it. But for now, if you're able to sort of mock this sort of this sort of mock runtime, this test runtime thing in the right way, in a compatible way with your blockchain, and then you build the environment, right? Then you can just test drive your migration and do checks. And now I can show you with this for this particular thing how, like, what we found. You can actually see it up there already. I had it there as well. So what it's doing now, actually.
Alex, can you maybe move your screen, the terminal up just a little bit, because the video boxes cover the bottom left, which is right where you're typing and stuff.
Ah, yeah, that sucks. Like this?
Yes, that's good. Thank you. Maybe if you could move it up just a little bit more.
Right. There we go.
Yeah, that looks good. Thank you.
So what you see here is some logging that I turned on where it connects, right? It connects to the node that we specified, and then it downloaded the data for fragment election for the module that we want to test, and then for the system, because the system palette includes the account data. And then it tells us, 209 voters migrated to this new version. That's this logging is part of the migration itself that we executed. And then it actually shows us something very interesting, which is that there are a bunch of accounts, that means 7 accounts, that don't have any reserve balance, even though we would expect them to. So these are voters, and in order to vote, we need to reserve some balance, and so we would expect them to have this kind of reserve balance. And so this is the I want to show that this is the inconsistency that we found with this testing method. Sort of you're seeing the live substrate development, so to speak, right now. We found this inconsistency, and there's already some there are already improvements on the way on what the cause of this might be and so on. But what I want to use this production use case for, right, is to show you okay, right, you can do these sort of checks, these sanity checks on your live data to see whether the assumptions that your migration makes hold true, and whether your migration create the right state, right? If this deposit here were any different, then the assert would trigger. So we can change this to, I don't know, 400. The assert, and then it will fail.
So if you had skipped this step and just run the migration without doing any testing, then potentially what could have happened is you believe that all these invariants are true, and so you think everything happened great, and then completely unbeknownst to you or anyone else, there are these 7 accounts that are there that are just messed up because there was some invariant that didn't hold true. And that is the worst possible situation that I could imagine being in, which is that there's something wrong, some broken invariant, and you don't even know that it's out there. It's like a monster swimming in your blockchain, basically. And so that it's so important to be able to do this.
Yeah. Yes, exactly. And as I said, unfortunately, is a little bit cumbersome right now, and we want to improve on it. So if you use the remote externalities, feel free to give Kian, give us feedback on it, so that we can improve it further and make this easier, so that we can have as little friction with this sort of testing as is possible, so that we can sort of test the runtime migrations. All right. So this is any questions about this sort of particular demo or test? Because otherwise I'll move on to it. Oh, there, Kian is there. Nice. Woo! Hi, Kian. Yeah. 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 Yes. Very good points. Thank you. No hurt feelings in the sandbox. I like it. Okay, cool. Any questions?
No, I think that was a very good demo, and I know that I still have a little more time. I know that you may have other things going on today, so if you need to call it quits here, that's totally cool. But if you have some time to show off some more stuff, I know that I would love to see it personally.
Yeah, sure. No, I planned until 5, so.
Sweet.
So I'm all good. Okay, cool. The other, so as I mentioned in joke to Dan beforehand, like I'm showing other people's work. So this was basically Kian's work, right? And we sort of found this particular thing together in a debugging session together. But yeah, this was basically Kian's setup. And so now the other thing that we're showing is a tool that I've used frequently, Forkless Substrate, in combination with a tool that I haven't used much, that Jesse mentioned, called Halva. And what we will be doing is something that's a little more integration test-like, because we won't just be running our particular one migration function in the sandbox. We will be running a runtime upgrade on a fork chain, and then testing against that one. And for that, so I'll be showing stuff. If Jesse wants to come to help answer questions about Halva and what you did there, that would be cool.
Yes, let me go ahead and find Jesse. Here he is. I'm going to go ahead and invite Jesse on screen. So halva, for those that don't know, is a type of confection, actually, much like a truffle. So for those of you who may be familiar with the Ethereum ecosystem, we're going to be showing off a testing framework that's named after a delightful confection. And with that, I'll hand it over to Alex and Jesse.
Hey, what's up?
Hey.
Yeah, and actually, Jesse, feel free to introduce yourself. You are also a runtime engineer like Alex, so we talked about that. But if you'd care to, kind of say hello, that would be great.
Well, not like Alex. Nobody can be like Alex. That's on his own. But yes, I am also a runtime engineer, and I joined 2.5 months ago, ish. I'm super pumped to be here. Mostly Ethereum until then, but I've dabbled a lot on Substrate and. Really fun process, learning more and more. I'm starting to do some real work with Substrate.
Okay, cool. So what we have here is a node template. So there's the Substrate node template, which is, I think, Dan, you're part of the team maintaining the node template, right? Thank you for having that playground.
Yes, that's us. You're welcome. Thank you.
So So there's the we have some storage item there that's just a number, and we will. So the idea is that we will take this initial state. This will be our initial runtime version 1. Right. The spec version here is version 1, and we will run it, and then we will fork off from that particular runtime to then introduce a runtime upgrade. And then depending on whether we migrate the data properly or migrate the data in a bad way, sorry, that's why you can say the bad chain and good chain on the screen right now. Depending on that, the data will either not be accessible afterwards or not accessible. So the end state should look like this, right, where we have some struct that's in the storage that is like some different format.
So Alex, would you say that what you demonstrated with the remote externalities was more of like a type of integration test? What you're going to demonstrate with Hall is more like a unit testing scenario? Or how would you compare and contrast the two types of testing?
Mm-hmm. So as you can see, this is a little bit confusing here because they're both sort of unit tests and both sort of integration tests. So I would have named them exactly the other way around, because the migration test that we just did, it just tested one function. Sort of, it did right, and so I thought of it as, oh, this is a unit test because it takes some sandbox state and then it runs one function and then you assert afterwards, and that, like, to me that seemed very unit-like. But of course, it's an integration test in the sense like it integrates the live state with the particular migration that we want to test. And then like now with Halva, I would say it's a bit more of an integration test because we're testing a runtime upgrade of the whole runtime, which includes our migration, but it includes lots of other stuff that's in the runtime. But then it also has a little bit of a unit test like quality to it, because we'll be running this test code which like does some assertions, and so
yeah, I mean, I can take over what we're doing on that, but pretty much it's like full out RPC calls. Like we make the call, we make sure that it comes to a certain state, then we do the upgrade and we make sure it comes to a second state. And as we're going to see, the test will just fail with the poorly migrated data because, you know, we just, hey, blockchain, what's the answer? And it just comes back. Well, you guys will see eventually, not to do any spoilers.
There we go. Let's purge this first. Most important flag ever to know. This is going to be minus y. Okay, so we have this chain running. So in a different environment, we will run the Halva test, and this one, so this one will just set the state. So it will do an RPC call. Actually, like Jesse, yeah, you can tell us what's happening here.
Yeah. So one cool thing, well, one maybe not cool thing or cool thing about Halva, depends on how you determine it, is that you're running your blockchain completely separately. Like not like a Nosh, which is kind of like tied. It's just a specific chain. It's like you run your chain, and so if you need to set any initial state, you can write a test to do that. And pretty much what I do is I check to see that they're in the try catch in line 12. I just see that, oh, cool, we haven't done a migration upgrade yet. So fire the call that's going to set an initial state so that we can test it and actually screw it up later. So pretty much just setting a state that we can, to storage that we can mess up later or fix properly.
Mm-hmm. Right. So these two lines, they set up the initial state.
Mm-hmm.
Right. Cool. All right.
Exactly.
So that's what we did. So now we have this node here, and actually we can keep it running. So now we'll switch to forkoff.
Yeah, I accidentally called it forkit. That's not me.
Yeah, I like forkit as well. Forkoff sounds so like so aggressive. Okay, so let's do the. Let's remove that, and then copy the bad chain to data. So forkoff expects the binary and the runtime to be in the data folder, and then it expects a node to be running. That's why we have the node running there in the background. So we can run the thing, and it will connect to the node, and then it will build a new chain spec called fork.json. That we can then run. So what happens here is it takes the state from the running chain that's running here in the background, and it collects the state from there, all the state pairs, and then it takes the runtime.wasm that we provided, and it sort of mangles the two together. So it substitutes the part of the state that determines the runtime code with the provided runtime that we gave it. So this actually means that on first start, and then it sets a few other things. So on first start of the blockchain, it will actually trigger a runtime migration. So I guess the first block will be a runtime migration. So this is the bad runtime migration. It doesn't really have any migration. So let's purge it first, and then
this is still in the target normal. You would have to go into the forkit repo and run the.
What do you mean, the other binary? Oh, so I'm running it with the same binary.
Oh, okay, cool.
That worked out, yeah.
Okay.
So that ran through.
Did we get
Okay, wait. So can you kind of? So I understood that fork off or forkit, I like both names, is a tool that essentially helps you turn a running chain into a chain spec. And then I missed exactly what you did. I missed what happened when you started that node that's now on block 6 there.
Right. Yeah, so I expected there to be some logging that we would see as part of the runtime upgrade, but there was none, sorry.
Yeah, I'm concerned that for some reason there is no logging. But we'll see if it works. If not, I think I know why.
So as part of starting the new node, the runtime migration would be triggered, which unfortunately is not visible right now. Sorry for that part not being visible.
Okay, so what you're running there, the node that's now on like block 12 or whatever, that is the node. It's a new node that was started based on this chain spec that we talked about that was generated from a running chain. Gotcha. Cool.
Yeah, it's like I could have pointed out this one, right? It's like local testnet fork. So the fork was added by forkit or forkoff. Right, and so we executed the Halva test, and it now tells us that the test is failing, and it expected a different sort of structure, because and so the storage was not what it expected it to be, because there was no migration that was run.
And so can we go back and look at the Halva code again? And I apologize, my network died, so I may have missed this. And if I did, feel free to skip over it. But I heard where Jesse was kind of talking about how he kind of sets up the state in Halva. But what else is going on in here that caused that test to fail?
Right. So the state gets set up to 12. And then after the upgrade, the something number that we put in, we kind of expect it to still be 12. But when we go to run the upgrade, it's not 12, it's 0. So it gets the default value because I believe it wasn't set, or it's either taking the Boolean false and converting it to a number. because we flipped the position of the Boolean and the UN64. So whatever the default would be was most likely what was going on there. If I explain that properly.
Mm-hmm. So it tries to decode the value in storage, but because it's not the format that it expects, it cannot do so. So let's purge this one again. And so now we'll want to run the the actual upgrade.
We have to run the normal chain first to fork it.
Yep. Exactly. So we can we don't need to purge this one. We can just keep running it because we didn't actually change this one in any way, right? And so we can just now go here. Cool. And then npm start. So this will now create a different fork.json that includes the other runtime, and let's see whether we can. Do you think we'll see any logging? I think on my test run earlier, I couldn't see any logging, unfortunately.
Yeah, that's so weird. Maybe it's a way that you didn't change binaries or something, because mine had it, but I assume that it should have. But yeah,
I think there's some interaction between like whether it runs the binary, like the native version of the chain, or the WASM, and then the logging behavior.
I think if you manually go into the config file and like erase the last thing, because it tended to be there even after running that. You know what? Ignore what I just said.
Okay, so now we're running the Halva test again, right? Darn test.
And can you just kind of reiterate what is different that you did the first time? Because I still am not quite sure what changed between the two different runs. Right.
So yeah, I should have shown the code difference first. So if we check out we are on master right now. So to show you the runtime code that we changed. So we changed this part of the runtime code, and now we'll switch to the good chain to show you what the storage looks like. Right, so the storage looks different here. And this is the same between the good chain and the bad chain. So I can also quickly check out the bad chain. The bad upgrade, right? This looks the same, but what looks different is the following: the runtime upgrade. So here we're not following my my best practices that I outlined, and instead we're just defining everything in the within the file directly. So here we have the on runtime upgrade, and this is the bad upgrade that doesn't have any code, right? It's all commented out, and then in the good upgrade, right, we have this migration. We we access the old state, and then we put the new state where it should be, and then we set the version, so that we know that the migration has happened. And
so where did I'm not quite sure where fork came into play, or fork off came into play with all of this. Like I see the two different. I understand that there's like one version of this change that basically doesn't have a storage migration, and one that does. But then where does the fork off part come in?
Yes. So right. I'm very sorry. This was a little more confusing than I thought it would be. So we have this forkit here, right? And we have what forkit does is it connects to the chain that is running. So for example, this one, and it will take the state from there, and then it will combine it with a runtime that's defined in the data folder, a runtime.wasm. So what I did was, because compile times are always a problem in live demos, right? We compiled both the good upgrade, which is this one, as well as the bad upgrade, which is the other one, which is commented out, right? And we compiled both of those to wasm and put them in here in good chain and bad chain, right? Both of these. Actually, you can even see that they have different code. This one is 262 kilobytes, and this one is 261 kilobytes. And then we forked off from the running chain from this one, and we took the state from this one and combined it with either the bad runtime. No, this is the good one. Either the bad runtime that didn't include an upgrade, or with the good runtime that did include an update.
And this is like super cool because, like, let's say you have a chain that you want to test the upgrade on live, and you don't have enough tokens to actually send through the vote yourself. What you can do is you can use this tool, and you can add a pseudo key that allows you to do it, or add a pseudo key that allows you to mint balance into your own account so that you can sway the vote on your own machine to actually like test it within the parameters of how the chain actually kind of works. So help you get around that issue.
Okay, I think I understand it. So I was under the impression that fork off basically just turned a chain into a chain spec, but it includes this other capability that allows you to kind of, as part of that process, swap the runtime in and out as well. Is that correct? Okay.
Yes. So
which makes sense. Go ahead.
Yeah. So it's totally right. So this capability of it takes a running chain and turns it into a chain spec is something that's just a very powerful thing. Like it's a little bit fragile. So if some of the assumptions change, then it will break horribly. But as long as that's not the case, it's a very powerful way of getting exactly the kind of chain spec that you want, and that includes the runtime. And yeah. Yep. So actually, we can look at the code to show what it does. If you want to look at forkit a little bit more, we can look at, like, I've spent way too much time with this piece of script to test Polkadot, so I'm oddly familiar. So right, it mucks about with the Genesis spec in order to so here it sets the runtime code, right, and then it changes the staking, the way that the consensus works, so that it's easier for testing, and then it deletes the last runtime upgrade entry so that it will trigger the runtime upgrade, and it will actually use the new code that we set.
That's pretty fun. All that gadgetry and that's neat.
Right. Yeah. I'm very sorry that that there were a lot of moving parts, and that the things that we wanted to demonstrate were not as visible as we wanted them to be. Right. So, but yeah, Halva itself, right? Like, so one of the things that we thought about doing, but then decided against, is like you could with a development chain, you could use Halva itself to just call a pseudo set code in order to then run the upgrade and then run some test. So that would also be possible. Something that we could show in the future, but we thought that the combination with fork-off was good because it works for any chain, right? I could just, and maybe I should have, yeah, but it would have been difficult because it's so much data. Like, we could have taken Polkadot and run fork off with Polkadot and then run a runtime migration on Polkadot with this, right? And so this works for a production chain, while Halva itself depends on the chain supporting the kind of testing that you want to do.
I think we did end up talking about that for a second, and we're like, nah.
Right. And then that's why we demonstrated it this way to sort of because the underlying method should work for any chain. That was the idea.
Nice.
All right.
Do you guys have more to present, or is that the end of it?
I was just about to say, so this I think this would conclude the demo. I think there's one last point that I wanted to make that's sort of like a little bit after the thing in terms of runtime migration best practices, and that is that the runtime depends on certain APIs in the node. So there is sort of a dependency relationship there. If you upgrade your runtime, you want to make sure before executing it that the nodes support your runtime and provide the right runtime APIs. I can show you quickly so that you know what I mean. Actually, let's go into the template. Actually, we can see it here. To show you what I mean. Yeah, right. So there's there's a version runtime API, and there is a metadata one, and block builder, and all kinds of validate transaction, all the core things on all the important things on how the runtime interacts with the node. So if we were to impl my awesome runtime API, right? If you added something like this to your runtime, then before you make the runtime upgrade, you want to make sure that all the relevant nodes in your network support this new runtime API. So you want to only execute the upgrade afterwards. Otherwise, you might get otherwise you might, even though you have a forkless runtime upgrade, you might still fork because the runtime APIs are not there in some of the nodes. I just wanted to sort of note that as a best practice to give a more complete picture.
So does that imply that those runtime APIs are only compiled to native? Why are they? I feel like you just said that it requires the node operators to coordinate updating the native node binary. Is that correct?
Mm-hmm. Yes. So the runtime API is an interaction between the node and the runtime.
The runtime, right?
And it's how this is called. Actually, like I guess I was not being very, very exact. So this is a way for the node to call into the runtime. Now that I'm actually looking at it, like I think I phrased it a bit poorly. But the general point that I made still holds true, where you like this is a way of bridging the divide between the node and the runtime. So in order to bridge that, right, in order to bridge that properly, both sides need to match up. So if if it doesn't match up, so normally when you have a runtime, you can just run it on a node, right? You just have your node, you just plop in the runtime, and when you upgrade it, it doesn't matter which version of the runtime you're running. It's just like you have your VM and it just does, right? But this depends on the APIs, and so if those have changed, then the node might not be compatible anymore. And I just wanted to note it. I haven't looked at it in a while. I don't know what might have changed recently. I just know that part of the edgeware migration, there were a few, like, because the time difference between before and after the upgrade was so big, there were some changes to the runtime APIs. And so to that interaction between the node and the runtime itself. All right.
All right.
That was a lot of stuff.
That was a lot of stuff. I mean, I don't think that we could talk about storage migrations without, with a little stuff. That wouldn't be a worthwhile talk on storage migrations. So thank you for taking the time to prepare all of this, Alex, and for taking, obviously all the time that you've spent learning it and everything. Yeah, I don't see a lot of questions, which I think is good. I think we did a pretty good job of covering things. So yeah, I think we're pretty safe to sign off and say goodbye. Jesse, you want to pop back on and say goodbye? Always makes me happy to see your face and hear your voice.
Thanks, man. Thanks, man. Yeah. Oh, Alex, that was fantastic. Thank you so much for doing that.
Thank you for the invitation.
Yep. And if I hope that you guys start playing around with this yourself. And if you do, there's the Substrate Seminar channel in Element. I'll drop the link to that. Jesse and Alex, if you have the opportunity to drop the links like to your whatever slides or demos that you shared. Jesse, I saw that you already did that. But Alex, if you need some help getting the slides good for sharing, I can help with that. So we'll either share those here in the Crowdcast or in the Element channel, which I'll share right now. So yeah, thank you very much for joining, everyone. I hope to see you next week. Yeah.
Sounds good. Yeah, I just posted a link to the Runtime Migration Best Practices Guide. It's sort of my, that's sort of what this this session was based on. I'm trying to sort of collect all of those in one place, and so check them out. Check it out.
Awesome. Thank you very much. I'm just looking to see if I can remember what we're talking about next week on seminars, so I can do a little teaser. Oh, next week, Josh is going to be talking about some Frontier and Moonbeam type stuff. So that'll be another great seminar. We've had a couple really good ones in a row here. So thank you for being part of this string of great seminars, guys. It was great talking to you. And yeah, I'll see you around.
See you around.
Later, guys.